So first of all, what is a single point of failure? A single point of failure is a part of your system whose failure can bring down the entire system. Okay? Now, we saw earlier how a load balancer distributes the traffic across the servers. But what if this load balancer goes down? As you can imagine, this will bring down the entire system. So this makes our load balancer a single point of failure. Now, to solve this problem, we can simply add more load balancers to our system so that if one of the load balancers fails, others will handle the traffic. This is known as redundancy because we actually don't need these additional load balancers. We are using them just to be fail safe. Okay? Now, there are two ways in which we can use these redundant load balancers. One is to use them as backups, which means that the redundant load balancers will be on standby and will only be used once the original load balancer fails. Okay? This is known as active passive redundancy. Another way is to use all the redundant load balancers actively to handle the traffic. This is known as active-active redundancy. Okay? Now, what are the advantages and disadvantages of each type? Well, active-passive redundancy is way easier to set up. But all the requests are still going to a single load balancer, which increase the chances of load balancer failure. And also, you are wasting the resources by keeping them on standby. So basically, one load balancer is doing all the work and others are just chilling. Okay? But on the other hand, active-active redundancy is difficult to set up and sometimes a bit expensive. But because the load balancers share the load, the chances of one of the load balancers dying are less. And also, there is no resource wastage here. Okay? So, the point is that you can eliminate single point of failure via redundancy. Okay?